There are some words on here, but I typed some of them in for you. That was nice of me. Okay. We're going to go through some theorems and postulates, but I think you will find them to sound familiar. Okay. We have what's called the corresponding angles converse theorem. Converse means we take a statement and we do what with it? Flip it around. If two lines are cut by a transversal so that corresponding angles are congruent, then the lines are okay. So in this picture, does it say anything? Are there parallel markings in this picture? No. But what this is saying is that if angle 1 is congruent to angle 5, then we could conclude that L is parallel to M. If corresponding angles are congruent, then our two lines are parallel. Sound fair? Okay. The alternate exterior angles converse theorem. If two lines are cut by a transversal so that alternate exterior angles are congruent, then our lines are parallel. You know what I love about the word parallel is that there is a pair of parallel lines in the word parallel.
Actually, there's a tree on substitution. It's just
True.
I mean, you could argue that there's actually
You would have an argument, depending on how you write your piece.
you could argue it's hard.
Okay, so in our picture, there is nothing marked. However, well, hello. If angle 2 is congruent to angle 8, if we have a pair of alternate exterior angles congruent, then we can conclude that L is parallel to M. Ooh, excuse me. Okay, sounds like we're done writing that down. All right. Alternate interior angles converse. If two lines are cut by a transversal so that alternate interior angles are congruent, then our lines are parallel. Okay, so in our picture, nothing is marked. But if, let's say, angle 4 is congruent to angle 6, then we could say L is parallel to M because of the alternate interior angles converse. Bless you. Doing okay, Josh Kane? Okay, excellent. All right. Now, what do you think needs to be true about our consecutive interior angles?
Consecutive interior angles.
Supplementary.
Supplementary would be the word. If we have consecutive interior angles that are supplementary, then our lines are going to be parallel. Okay, so if we have nothing marked, but we have something like, I don't know, the measure of angle 3 plus the measure of angle 6 is 180 degrees. If we have consecutive interior angles that are supplementary, then L is parallel to M. Okay. Then a couple things that just need you to know. Okay. Our parallel postulate. So I'll make sure I get my words right. If a given line and a point not on the line then there exists exactly one line through that point that is parallel to the line. Okay, so what this is saying, I have a line and I have a point off the line. I can only draw one line through that point that is going to be parallel to the first line. Only exists one and only one. Do you buy that? I have a line and I have this orange point, coral, whatever you want to call it. This is saying I can only draw one line through that coral point that is going to be parallel to the blue line that I drew. Does that seem reasonable? Yeah. We good? Kind of? Why only kind of? Okay, so we got the blue line, right? We got a point away from the blue line. If I draw a line I can only draw one and only line through that point that is parallel to the blue line. I can't draw two different lines. I can't draw three different lines, only one. Okay. It's one of those that feels kind of like, duh, but we have to like officially say that it's a thing. Okay, and then I feel like this is another one. Okay, if two lines in a plane are perpendicular, okay, so I have two lines in a plane that are perpendicular. That's what's happening right now. Okay. Oh, to the same line. So I have two lines that are perpendicular to the same line. What's going to be true about them? Yep. Okay. So if we go to the top of the next page, I have quite the picture here. Okay. I have two different sets of lines that to the eye, they look like they could be parallel. We don't assume anything. We can only say that lines are parallel if we can use one of these theorems right here. Okay? So what we're going to do is we're going to look at the angles in question. Does it give us parallel lines and why? So here is angle 9 and here is angle 6. My first question is, do they both touch one line as a transversal? Yes. Who's the transversal? C. Okay. What kind of angles are 6 and 9? They are alternate interior angles that are congruent, forcing which two lines to be parallel? A and B. C is the transversal, so we look at the other two, okay, A and B. So we're going to write A is parallel to B because of our alternate interior angles converse. Okay. So now what I want you to do is at your table, I want you to fill out B through F.
substituting?
Which ones?
Because 10's a cube and 3 is obtuse. Well, I suppose 3 is equal to 11. But I don't know.
What is this statement that like if 3 were to equal like 16, then we could substitute it 16, then 3 for 16, and then put it 11. But I don't think there's anything like that.
And then 1 and 16 don't share. So would you no relation? Would you be able to substitute 3 down to 11?
If they don't share a transversal, it's not going to work. Okay? Okay, so I have a question first of all. Did you find any that did not work?
Yes.
Okay, Kale, give me one that didn't work.
3 does not equal 3 equals 10. That doesn't even make sense.
Okay, so 3 and 10, they don't share a transversal. So there is nothing that we can do with that one. Okay? Was there any other ones?
1 and 16.
1 and 16 don't share a transversal. Okay. So then, how about 12 and 13? 12 and 13, who's the transversal? B, which means J, which lines are parallel? So C is parallel to D because, did you write alternate exterior angles? Converse, okay. Excellent. 10 and 11 are supplementary. B would be our transversal, so who's parallel? Because consecutive interior angles, converse, they're supplementary, right? Okay. We've already talked about 3 and 10. What about 8 and 16? Who do they make parallel? A is parallel to B because of our corresponding angles converse. Excellent. Okay. So, couple things you're going to have to do. Number 1, you're going to have to decide which lines are parallel if the given information is using one of these converses. I'm also going to have you algebraically force lines to be parallel. Kale and Sam, could you join us, please? Thanks. Okay, so if I want A and B to be parallel, what am I going to have to do with these two expressions? Okay, I'm going to have to set these equal to each other. What converse are we using?
Oh yeah.
Okay, so since we have alternate interior angles and we want parallel lines, I'm going to force them to be incongruent so their measures are the same, which means 10x equals beep, beep, boop, boop, 160. So x equals 16. Done. Got it. Love it. Okay. What about this example 3?
Oh, it's the perpendicular.
Oh, yeah?
Transversal converse theorem.
The perpendicular transversal converse theorem. So what do we know about 4y plus 10? It better be a 90-degree angle so that we have E and F parallel to each other. I think we're solving for y. And what would y equal? Okay, I was like, man, am I not calculating this correctly?
Oh yeah, that would be.
Okay.
Okay.
All right, so it's our favorite time. Proof time.
Is it
What?
toes?
All right. While you turn to the next page, I shall look up your lunch. Oh, Hickory Hill.
Wait,
I know. Riker had to look up on my phone what was for lunch. Just like Hickory Hill, crispy chicken sandwich or fiestada.
Why have we had that same lunch option like 2 days a week for the last like 3 weeks?
Okay, here we go. Let's go ahead and write in that angle 3 and angle 8 are supplementary. Can you tell that says supplementary? I thought so.
No.
I didn't get it fit, so I just scribbled a little bit. Okay, we eventually want to prove that L and M are parallel, okay? Looking forward, if I want to prove that L and M are parallel,
we should do the thing where like it becomes an M.
if I want to end with L and M parallel, what two angles do you think we need to focus on being congruent?
3 and 7.
If we can show that 3 and 7 are congruent, then we can say L is parallel to M. Okay? So, right now I have 3 and 8 are supplementary.
Do we have to do like the measure of 3 plus the measure of angle 8 is 180?
I think that's a good idea. And what would be our reason? Definition of what definition are we using?
Supplementary.
No, supplementary.
Or don't we need to like make it congruent first and then do that?
We have nothing that's congruent right now. Okay? But whatever we have in the given, we need to use in some fashion. Since my given is, hey, these guys are supplementary, my next step needs to be something with that. Okay? If we look at the picture, do we have another pair of supplementary angles up there? Which ones? Okay, so what I'm going to write is that the measure of angle 7 plus the measure of angle 8 is 180 degrees because they're a linear pair. We have something called the linear pair postulate. But honestly, if you just put linear pair, I'm cool. Oh, what did you say? We could use substitution. Since these both equal 180, then I can set them equal to each other.
Wouldn't it be measure angle 3 plus measure angle 7?
Oh, and that was subtraction.
Like
Why would it? So I took this and put it here.
No, I got it.
And I took. Okay. But now, Logan, what can we do to both sides?
Take away 8.
So we can use what we know as the subtraction property. Since there's a measure of angle 8 on both sides, we can subtract it from both sides. Now what can we do?
Oh, we could do the
corresponding.
Not yet?
Not yet. Not yet. Oh, definitely.
Let's do our definition of congruence, and then we can do our corresponding angles converse. Cross country, you think you're gonna run in the mud today?
Zeus, please.
Zeus. Okay. Do you have questions on this example for proof?
What?
Do you have questions? No. Okay. Let's look at this last one. We know right now that line C is parallel to line D, and angle 1 is congruent to angle 3. Okay. I want to prove A is parallel to B. Ugh. All right, let's start with our given. I'm just gonna angle 1 congruent angle 3.
Oh,
Okay. In my opinion, we have two different ways that we can do this. Okay. If I want A is parallel to B, then I can either use the corresponding angles converse or the alternate interior angles converse. Philly?
We put 1 instead of 4.
That is one.
This is angle 1.
Oh.
I thought that was
I can
Is that better?
Yeah.
Okay. So, do I know anything about angle 1 and a different angle?
Yes. 1 and 4 equal. Each other.
1 and 2 are equal.
Angle 4 and angle
I-
1 and 3 are equal.
I think we only know angle 1 and 2 are congruent because C and D are parallel, right? Okay, so we can say angle 1 is congruent to angle 2. Why?
Because they're alternate.
Is this the converse? No, it's not the converse. It's the original theorem. Okay. Alternate exterior angles are congruent. Okay. So angle 1 is congruent to angle 3. Now we have angle 1 is congruent to angle 2. Does that tell us anything?
Oh, yeah, I said 1 and 3, then it's 4 changes.
Angle 2 is congruent to angle 3 now by either transitive or substitution. Potato, potato. Is that enough?
I think it is. Because now both of those are flipping A and B.
Yeah.
Huh. So now I think we can say A is parallel to B. Why?
Alternate interior angles.
Look at us go.
Oh, yeah.